Okay, so the idea for Fadum's chart, right, is to find the change in stress of one point below ground caused by a rectangular area load. So for example, I have an area like this, 3 meters by 4 meters, and then I apply load of 120 kilopascals. And this is the point that I'm interested in, which is point A. This one is top view, by the way. Then for the side view, A we know is 10 meters below ground, for example. Okay, so now they ask, what's the change of stress at A? So to do this, first we need to find M and N. So M and N are, if you see here, M and N is just the ratio between the breadth and the depth. So in this case, for M, it's just 3 divided by 10, which is 0.3. Then N is just 4 divided by 10, which is 0.4. Just take note that M and N are interchangeable. So if you want to make 0.3 as N, 0.4 as M, that's also possible. But for now, let's stick to this. Okay, so after we find M and N, we just go to the chart directly. So, for example, M equals 0.3, so M, so 0.1 is here, 0.2 is here, so 0.3 is here. Then for N, 0.4, we refer to the curves. So for example, 0.4 is this curve. So we just follow this curve, and then we just bring the line up and bring the line to the left. You will get around 0.044, around there lah. So this is what we call the IR. Okay, this one is the IQR. Okay, so what's the change in stress? It's actually your Q times IR. So Q here is your 120 kilopascals multiplied by the IR, which we just now found is 0.044, and that's your answer in kilopascals. That's the change in stress. Okay, just take note, when you're using Fadum's chart, the condition is the point of interest must be at the corner of the rectangle. So in the case that you have, for example, you have something like this. Let's make this a rectangle. Okay, for example, this is 20 meters, this is 10 meters. For example, A is 5 meters below ground, for example. Okay, then A is located somewhere here, for example. It's somewhere in the middle. Let's say this one is 5 meters, so this one is 15. And then this one is, for example, 4 meters, this one is 6. Okay, so you cannot just use Fadum's charts using 20 and 10 directly. Okay, you must locate A, you must somehow make A in the corner of the rectangle. So what you can do, right? Okay, by the way, this one, for example, is 120 kPa. So what you can do with this area is split it into 4, for example. Okay, in this case, you have 4 rectangles, 1, 2, 3, and 4. And A is located at the corner of each rectangle. So for rectangle 1, right, is this rectangle. So for rectangle 1, M is just 15 divided by 5, so that's 3. N is just 4 meters divided by 5, so 4 divided by 5, so that's 0.8. Then you just use the chart to find delta sigma, so just 120 times your IR. Then you have rectangle 2, you find M and N for rectangle 2, then 3, then 4. Okay, and then you can find the change in stress. Then it's just the principle of superposition, you just add everything up. Okay, and then just take note that you can also have negative area. So for example, you have an L area like this. For example, it looks like this. Then your A, for example, is located away from the thing. So for example, it's like this, A. So for what you can do is, for example, this is 5 meters, this is 10 meters, 5 meters, 10 meters. A is, for example, 2 meters below ground. So what you can do, right, for example, for this case, is just your big rectangle. So like this one is A minus the small rectangle. Okay, this one is A. And then for the dimensions, this one is 10 meters, 10 meters. This one is 5 meters, 5 meters. So in this case, M is just 10 divided by 2, which is 5. N is also 10 divided by 2, which is 5. This one, M is just 5 divided by 2, 2.5. N is 5 divided by 2, 2.5. Another example is, for example, you have a rectangle like this. Okay, this is a rectangle. This is 100 kilopascals, for example. A is located somewhere here, for example. This one is 6 meters. This one is 4 meters, for example. Okay, so again, this one is just equals to your big rectangle. So big rectangle is like this. Okay, so this whole thing. So this one is A minus your top area, which is like this. Okay, this one is 100. This one is 100 kilopascals. Then this one is just 10 meters. For example, it's 10 meters, so this one is 10 meters, this one is 6 meters. Then just find the m and n for each, then find delta sigma, then just minus. Okay, and then just one last example. For example, you have a few areas, for example like this, then you have for example, this area is loaded by 200 kilopascals, this area is loaded by 100 kilopascals, and for example this one is A. So remember, right, it must be at the corner. So what we can do, right, is for example this whole thing 200 kilopascals, so this one is A. Okay, actually let's make this 300 so it's more obvious. Okay, so 300 kilopascal, for example 6 meters, 4 meters, so this whole thing is 10 meters, 5 meters, so this one is 5 meters. You just minus off by this, sorry, what can we do? Yeah, we can minus off, correct, we can minus off the right side. So the right side is just like this, we just keep A here, but we minus off by 200 kPa because we want to replicate the 100 kPa condition. So this one is 5 meters, this one is 4 meters. Again, just find the delta sigma, then you just minus off the 2 because it's just superposition. And that's it for Fadum's chart.